we might actually be live. Give me a second to turn on my lights, wherever they may be. Well, I suppose. There we go. Oh, well, I've unplugged them. Hi, everybody. Welcome. Welcome to another live stream session. Hopefully, I am audible. If I'm not, please post some comments in and let me know. We're going to talk today a little bit about the hackathon that's coming up in the GSF. I'm going to talk a little bit about the Carbon Hack itself, what you can expect. I'm also going to give you a very quick introduction to Impact Framework, However, unfortunately, I bought a new MacBook, and I have not managed to get get it quite working on my laptop so far. But I'll take you through all the motions, because what's important with the Carbon Hack this year is Impact Framework. Just let me show you a banner. Here we go. So this year we are launching Carbon Hack. If you want to sign up for Carbon Hack, that's a link to go to sign up to. The eagle-eyed of you who might have seen some previous communications over this would notice the dates have changed, and yes, they have changed a very little, but we've pushed it forward 3 more weeks just to give everybody a little bit more time to prepare. So now the hackathon will start on Monday, March 18th, and it will end on Monday, April 8th. And then there'll be a ceremony with award giving a week or so after that. Let me go to the next slide. Let me change the view a little bit. I think this one. Oh, no, this one's good still. So this year in Carbon Hack, it was something we ran in 2022. It was a massive success. We're very excited about it. This year, I'm very excited to talk about Carbon Hack 24. We skipped 23. 24. So it's all about measuring software emissions. Measuring is the really key point that we're focusing on this year. We've all finally reached the point where we can measure. Please feel free to say hello. And if you've got any questions, by the way, fire them away using whatever channel you are at, and I will try and get to them later on, or during the show. And feel free to say hello from wherever you are. This year's Carbon Hack is about measurement, and very specifically, it's about measurement using a tool which is being built in the Green Software Foundation called Impact Framework. Impact Framework is an open source project that attempts to help you calculate, the emissions of a software application. And I'm going to show you how it works. It's not something you install. It's something that you use to reason about and really be very transparent regarding these are my application emissions, how you share applications emissions. The dates are still wrong in here, but anyway, the dates are March 18th to April 8th, so that should be what's on the website right now. It's a hackathon, which means it's dynamic competition. You can compete by yourself, or you can form small teams if you wanted to. And I'll talk you through a little bit about what we're looking for and what the prizes are, and what we're looking for you to build using Impact Framework. But effectively, it's measuring helping to improve the ecosystem of measuring software emissions using Impact Framework with something called model plugins or contributions to the framework, or even we're introducing this time around content, so you can win a prize for creating an excellent video tutorial, things like that. So we're really hopefully opening the doors to some non-technical contributions as well. If you are working for an organization that's interested in this area, and would like to sponsor, we have a sponsorship opportunity as well. And if you go to the website Hack24 and you scroll down, that's where you can find the sponsorship pack and information there. Sponsorship is a very reasonable $5,000, and for that you get seat on the jury, logo on the website, mentions in social media, but also more specifically, if you actually do have, like, I imagine if you're sponsoring this event, you're sponsoring because you're thinking about measuring software emissions, or you've got a challenge. Um, I would love, like, I'll invite you onto this call. Like, if you want to sponsor, let's have a session. We'll walk through what are the challenges that you have regarding measurement, and we'll try and craft like a hackathon idea, which we can post on the hackathon platform, which then other people can maybe solve. And if you really are looking for like inspirational ideas for like ways of solving a pretty gnarly problem you might have in this software measurement space, this might be a great way of getting some interest in it. I mean, and also we really are looking for great examples. The tougher the better for measuring software emissions, because that's where we are right now. We want to solve that problem. We have a couple of prizes in this area. We've got, best model, and I'll talk to you what a model is. Best content I mentioned before, like best tutorial on how to use Impact Framework, best contribution to the framework itself. So like Impact Framework is a series of repositories on the Green Software Foundation website, and if you contribute to those repositories, then there'll be a prize for the best contribution there, and we'll be proposing kind of little things that you can work on there. We've got a prize called Beyond Carbon. So if you're building a solution, building a model which helps us measure emissions beyond carbon, beyond just, well, carbon like maybe waste, water, air, that's a wonderful place to, that's a prize that will be focusing, that's a prize for you. And also, we think a lot in the foundation about the next generation. For some of you, this is your current generation, but the next generation. So we really wanted to make sure there's prizes here and incentivizations for people who are just coming into their career. And so there's a prize also for best undergraduate. So if your entire team is made up of undergraduates, students, then there's a prize for you. And we've also just figured out, I believe, the legalities around this, but we'll be launching an under 18s prize category as well. So if your entire team is made up of under 18s, then at the point of submission, then yeah, there'll be a prize for you also. So we've got quite a few different prize categories: non-technical, technical, and also focusing on the younger generation, the next generation as well. Important dates, not just for sponsors, but for everybody. So the hackathon's going to be announced. It has been announced in December. We're going to launch the registration platform, and it's actually just going to be a GitHub repo. The registration platform is a GitHub repo. We're going to interact on GitHub via issues and things like that. So we'll be launching that on the 22nd of January. The hackathon itself begins on the 18th of March. So between January and March, if you've got like a rough idea for something to hack on, post it on the hackathon website once it's launched, and we and the rest of the Impact Framework team will kind of get involved on your issue and say, well, that's a great idea. Have you considered this? Have you considered why? We would recommend you go in this approach. We don't just, this is not just like a competition where we just want to throw you to the wolves. We really want to help and nurture and support you, because we want you all to be successful. That's the best thing for us in Impact Framework, if you all are building amazing solutions on there. So there's a lot of work we're doing in terms of mentoring and support and nurturing, which is why there's such a distance between registration and the hackathon beginning. The hackathon is a 3-week hackathon, so it starts on the 18th and goes to the 8th of April. And the closing event and award ceremony is going to be on the 18th of April. So there's a fair amount of time, but there's also, we understand this framework's new, and you might just have an idea that's very broad in nature and need some help in order to kind of narrow that down into an area. And also, you may need help to kind of formulate a team. So we're giving you a lot of time to formulate that. So, once next week or the week after, I believe, we'll be announcing the platform. We might announce on the 15th, actually, if we get everything done by the end of this week, but we'll see. And then as soon as that arrives, you can start posting your ideas and you can start hacking. We ran it last year. There were 51. Let me get rid of this little banner at the bottom. There were almost 400 people taking part. There were 51 submissions by the end of the day, and we had the first place with we just last time we ran it, we just had one prize. So it was just the first, second, and third place, which were some amazing solutions. I mean, really proud of a lot of them. A lot of the work that we did last time, it was on carbon-aware computing, and we really kick-started a significant momentum in carbon-aware computing. And this year, we're hoping to really kickstart significant momentum into measuring software emissions, which is why we're focusing on impact framework. So let me go here. So are you ready to, so if you're ready to sponsor, I should say that, well, I've took this from the sponsorship deck. I do apologize. If you're ready to sponsor Carbon Hack, go to grunsoft.org hack/sponsor form, and you can fill in the form. Or if you've got any questions about Carbon Hack, or whether it's sponsorship or participating or anything, it's carbonhack@greensoftware.foundation. So this is the email address that you should contact us on. Okay, brilliant. So there's a question from Annie Pennell. There doesn't seem to be a category for a plugin that's using carbon measurement. No, that's the model plugins covers all of that. So model plugins is by default, most of what we do is with carbon measurement. So I would say that everything by default is typically carbon measurement these days. There's just one category for beyond carbon. That's all there is. There's one category extra for just talking about non-carbon impacts, if that answers your question. But yeah, everything else, normal model plugins, everything else is typically all by default carbon measurement, just because where the conversation is these days. That's where a lot of the models that we built are these days. So if you want to learn more about Impact Framework, do I have a banner for that? No, I do not. So yeah, if you could just go to if.greensoftware.foundation, that's a documentation site for Impact Framework, if.greensoftware.foundation. And also that's the GitHub repo for Impact Framework is Green Software Foundation /IF. I'm going to talk a little bit now about Impact Framework itself. Yeah. So there is that's just, I'm trying to, Annie's asked, I thought model meant making an actual model. And there is some language that we perhaps need to shore up. And we will be making that language a lot clearer. It is an alpha product right now, and it has evolved a lot over the last year. We tend to just still use the terms we were using like a year ago, whereas the way the framework has evolved, it's not. I think the term model kind of is confusing at times. But I think that's the term we're still using right now. But when we talk about models, we're just talking about a piece of code that takes some inputs and gives you some outputs. That's all we really talk about when we talk about model at the current moment in time. So what are the main components of Impact Framework? Right. So there's these things called model plugins, and a model plugin is just a small unit of code. It can be a function or two functions long that measures, perhaps an environmental impact from some observations about a running system or something intermediate along the way. So we've got some model plugins right now, for instance, that take CPU utilization and turn that into energy. We've got other model plugins that take energy and turn that into carbon. Model plugins are just really small, nice little reusable bits of code, which I'll show you later, which you can just chain together to perform really complicated impact calculations. So that's what a model plugin is. And the more model plugins there are, the more types of calculations you can perform. A manifest file is the file that contains all of your workings, and I'm going to show you examples of this later on. A manifest file is just it's a YAML file. When people tell me what I've calculated carbon emissions of my application as X, I'm like, okay, great, thanks for telling me. I want to know every single assumption that you made when you calculated that value, because that's where I find this gets interesting. That's the point where I can really compare and contrast. That's the point where I can say, oh, interesting, you used that assumption. That's not the assumption I would use. I would use this assumption. So in order to get to that point, we need a fully transparent world where we're not just listening to somebody's output emissions value. We're reading or we're seeing exactly how they calculated that. Full transparency is what this is all about. That's what a manifest file is. It's that full transparency. When I'm calculating a piece of software, this is every single thing that you need in order to recalculate the value I came up with is in this manifest file, and I'm going to pass you this manifest file, and you can rerun it on your own computer and verify my results. That's a manifest file. And the impact engine is the actual thing itself. It runs the manifest file and it calls the model plugins. So that's basically, yeah, and let me just quickly show you a manifest file. Here we go. Let me bring up my, here it is. So this is one manifest file that we've created, and it's in the Impact Framework repository. And it's a YAML file, and you can see at the top there's just some general metadata that you write. This is one called MSFD eShop, and it's actually a demo application called MSFD eShop. And then at the top you basically have to say, in order to, and sorry, let me jump to the bottom. It has this concept of a graph and children, and it actually has a nested tree. So when you're calculating a piece of software, what are you calculating? Like, what is it you're calculating? For this application, we can see straight away we're going to calculate something that's a front end, something that's an app service, something that's a database service, something that's networking. Maybe if you had a mobile application, you want to count that in. Maybe if you're using some APIs, you want to count that in. It's all about being fully transparent. So you're saying, what is it that I'm calculating? When I'm telling you the carbon emissions of this application, what components did I include in that calculation? That's what a manifest file contains. Inside each component, it has a couple of things. It has the most important thing is some inputs. So this is a terrible inputs because it's 0. Let me pick an app server perhaps. So you can see these inputs are this is one input. So for this time, for this duration, which is 1 hour, the CPU utilization on that server was 18% utilized. Your goal and the challenge that everybody faces in emissions calculation for software these days is, how do I convert something I can measure, which is something usually like utilization or billing data or network transfer, how can I convert that into an impact metric, be it carbon, waste, water, whatever it is? How can I convert that? Now, in order to convert that, you use what we call those model plugins. Each of these model plugins, what it does is it takes this data, you pass it into the first one, and each of these things know how to do one type of calculation to kind of iteratively move a computation from something that looks like utilization to something that looks like carbon. That's what it looks like. And that's the purpose. And these are all just little bits of code that you can execute. That's why it's perfect for a hackathon, from a hackathon perspective. And so here we're using 5 models, eShop and CPU, which converts CPU utilization to energy. Then this does some utilization. This adds embodied carbon. This converts that to, well, you can see here, energy per grid intensity kind of gives you the carbon for the grid. And this does what's called an SCI calculation. SCI is a type of software carbon intensity specification, measurement specification, which we've got at the foundation. So that's what we've got for the front end. So this manifest file has everything you need. When you say my carbon emissions for MSFD eShopping is X, you're not just saying that, you're passing somebody this manifest file, and it has every single assumption. Now, a lot of this stuff requires kind of configuration and some sort of coefficients. Each of these models has some sort of coefficient which it needs to use. These are then, you can provide that config as well yourself. And again, all of this is in the manifest file. None of this is buried away in a PDF. This is fully transparent, fully transparent. So again, when you hand somebody your emissions, you're just sending them this manifest file, and that's it. And that's it. That's what a manifest file is. That's the power of a manifest file. It is fully open, fully transparent. Everything you need to compute carbon emissions is all embedded in this manifest file. Manifest file is the core of Impact Framework, as well as this kind of pipeline of models. Now let me go back to, I've got a question from Lauren. What methodology is this manifest file built from? Um, I'm not too sure what you mean by methodology, but effectively, it's very flexible. And depending upon the model plugins that you um, pull from the ecosystem and put in a pipeline, it can calculate whatever methodology you want. You can calculate right now what a lot of the work that we've done so far, just because a lot of the people involved are from the Green Software Foundation, and our main methodology is a software carbon intensity specification. That has been our main thing that we've been driving towards. A lot of our models exist there. One of the things I'm hoping from the hackathon is that, you can theoretically, let me go back to the stage. You can theoretically replace, this. What has this done? This has calculated some energy. You could take that and you can maybe compute a GHG protocol, scope 2 perhaps, or something along those lines, if that's what you wanted to do. You could then have a GHG one, which instead of doing this does embodied from an SCI perspective, it could do scope 3 from a GHG perspective. It's very flexible. Your methodology is dictated by the plugins that you have. And the world that we have currently right now is everybody's building these big monolith bits of code that calculates everything end to end, and you can never reuse anything. One of the things we've realized is a lot of the functionality and the logic is the same across all these different methodologies. If you could just cherry pick this part of the function and replace it for this, you've got a completely different methodology. If you can cherry pick this and replace it with this, instead of measuring carbon, you're measuring water stress. So that's kind of where we're coming from, is we're trying to break it all down to these little micro models. And once you've broken things down to micro models, you can really do, that can really you can really kind of implement multiple different things. Awesome. I think I just answered your question. Let me go back to the thing. So I showed the manifest file. Let me talk very quickly about model plugins. So this is a really good quote. Chris Adams, I copied him. All models, well, it's not his quote, but all models are wrong. Some models are useful. George Box. So I love this quote because the truth is, yes, we're all about models. 100% everything you're seeing here is a model. But really everything is actually a model, because trust me, even when you're getting something that looks like an energy value, it's actually a model which is using some other set of counters to figure it out. Even when you've got a power meter on the wall, it's just everything's a model, right? It's just more how refined is the model that you're using. When we talk about models, we're just talking about things that take inputs and give you outputs. But it's really powerful. As soon as you start modeling everything based off of other models, you get some extremely powerful results as a result of all that. And I'll go through that in a second. So when we talk about it, we talk about this idea of an observation and an impact. So one you saw in the let me go back to this. So one of these blocks of time. So this is one block. It can have multiple blocks. That's a single observation. And an observation is something that you see, it happens at a particular time, it lasts for a particular duration, and it's an observation. It can be utilization, it can be billing data, it can be number of users, it can be network traffic, page views, whatever it is. That's a single observation, is one of those things at a particular time. A model takes one of those and can create an impact or some sort of intermediate impact, maybe energy or carbon or something along those lines. That's all that model is. It's trying to take an observation and figure out kind of what is the impact from that observation. So, and historically, there's been a lot of what I now call monolith models. So these are big models which try and do everything all in one. You give me utilization, and I will tell you carbon. Now, the truth is, to get from utilization to carbon, you have to make 100 assumptions, and there's 100 coefficients baked into this model. What are they? Do you agree with them? Do they work in your use case? This is the constant problem that we have with these monolith models, is everybody's use case is just a little bit different. And so when people are using these big monolith models, it's always being used with a, this doesn't really work for us. It's giving us averaged out data. It's not really telling us information that we need. But it is giving us, at least it's giving us a value. That is kind of where we are right now. It gives you a value. So congratulations. But we can do a lot better. There's other monolith models. This one, like for instance, takes billing data and gives you carbon emissions. But again, there's a whole bunch of assumptions baked in. How is it doing that? What coefficients? What does a dollar value equal? Is it configurable? Is it not configurable? You know, these monolith models do a lot in kind of one of these calls. What the design paradigm and impact framework is what we call micro models, like chaining together micro models together. So, you know, we'll have the same impact. We'll have something that we can chain, instead of having one model which takes utilization and gives you carbon, we will chain together three smaller models. Three models which do one thing and do that one thing really, really, really well. You might get a model which takes that utilization and turns it into energy. You might get another model which then goes, well, hang on, how clean or dirty was the grid at that moment in time? Okay, let me grab the data for that. That's the grid emissions. Another model which then kind of like multiplies them both together to give you carbon, and then you pump that out. With this approach of kind of like breaking things out into these little micro models, an amazingly powerful feature comes along. Suddenly, you can start doing a lot more with micro models that you can do a lot more with a small set of micro models than you could with one of those monolith models. And the only way that works is if there's a standardized interface. You can't just make your model output whatever values or whatever fields that you want. It's got to output this field, and that field has got to be these units. We have a standardized interface. The models have got to have this function signature. It's got to have this. If it throws this exception, this is how we will respond. It has a very standardized behavior. And that's the power of what we've done in Impact Framework, is we have standardized the interface to these models. And through that, we can then chain them together and have really powerful effects. And I think I showed that already. I did show that. I showed you the. Oh no, let me show you a different one then. This was my trigger to show you something. So here's another example, which is kind of a little bit smaller, a little bit different. So here I've just got one node in my graph, which is just a server, and in that server I've got a couple of different models that I'm plugging together. Now, fortunately, as I mentioned before, this is a brand new laptop, and I have not managed to set it up to run anything just yet. So apologies. I love my new laptop, but I forgot that you need to set it up, so I didn't, and I apologize, I didn't get it set up in time. But there will be lots more videos in the future. So in this one, this is just a different type of model, and this one we're using something called Azure Importer. You can see there's different models here that you didn't see before. There's so many different types of models that you can create. A model is, again, just something that takes one of these as inputs and gives you some outputs. What this particular model does is we've got some data running in Azure, the cloud instance, and I can't be bothered to kind of like pull that in as static data in here. So I've left it in there in Azure, and I can kind of run and say, like, give me data about my running instances in Azure and pull that out for me. So that's all that the Azure importer is it kind of grabs all that utilization data. And this is the data it would pass into it. Like, give me, for every 5 minutes, I want to have average values. This is I probably shouldn't show you. Well, yeah, I think that's out of date anyway. And then that gets then passed to this one, which enriches it with other data, such as, you know, region and other little factoids. I'll explain that in a. What this model does is it basically converts that into energy, and then you recognize some of these. This is like the set of the four horsemen of the apocalypse. These are the psi models, which help you take kind of energy and calculate embodied and eventually help you get from energy to carbon emissions. I just want to show you kind of a little bit there, kind of that's your pipeline, and you can have a different pipeline for every single component that you have. You know, we've got one here. You can actually these aren't these are just modules that you import on your path. You can see here, these are just different models that we've imported, and you can give it your own name that you want, and they come from whatever file that it wants, and it can even have its own configuration, global configuration. And what I want to show you explicitly here is that this whole framework's been built using TypeScript, but you don't have to build your models in TypeScript. Your models can be built in any language that you want, as long as it can be run as an executable. We have a different interface. So we don't call it as a function, we call it as an executable. But as long as it can be run as an executable, we will then call it and then use the values from that. So your models don't even have to be written in TypeScript. It's better if they are. They will be more performant most often. But if you, for some reason, have a lot of logic and a lot of code, or you feel it's better writing in a different language, or you just feel more comfortable writing in a different language, you can write your models in a different language there as well. So that's kind of how that works. And unfortunately, this is normally where I would run it, and I didn't have time to fix my computer. So that is lame, and I do apologize. But let me add this back in. Okay. Any more questions? All looking good. Feel free to fire away with any questions. All right. Cool. I want to talk a little bit about model taxonomy here. So this is something that we're still developing in the foundation with regard to impact framework. Because everything's made up of models, you can start doing some very interesting things. And one of the questions we get a lot over the years is like, okay, great. We know how to measure the carbon emissions of a virtual machine or something where I own the machine. What I'm struggling with, Asim, is my software is using so many services for which I have no information about what the carbon emissions of that service would be. And a common use case that comes along is like serverless functions. So serverless functions in the cloud space is like just a different way of executing code in the cloud. But you don't know. You have no idea what machine it's getting run on. You have no idea what utilization. You have no clue how to take any of that information and turn it into carbon. How do you even start that story? So in the serverless space, you get something called gigabyte seconds. You get charged for like how much memory you use and how long it's running. This is where we focus in on with respect to one of the types of models that we want people to build, and that is an adapter model. So an adapter model is a model which you can then adapt. So take something which is like 34.5 gigabyte seconds, and as long as that can output utilization, as long as you can adapt that value to utilization. If you remember here, there's already a set of models that can take utilization, that can get you from utilization to carbon, So all you need in order to measure serverless is just to get something that adapts, that creates gigabyte seconds to utilization. If you can get that distance, there's already models which take you the rest of the way. And that's the beauty and power of a micro model architecture. You don't have to do everything end to end yourself. Everybody worries about their small piece of the pie. And if you could just figure out that, you can calculate that. That's the beauty of it. That's what an adapter model is. So we want lots of adapter models to be built. How would I build an adapter model for Azure, for a server, for let's say Azure Functions? How would I build an adapter model? Well, I would probably run some infrastructure, some open source serverless infrastructure, and put it under the same amount of load that I would put under Azure Functions. And then you have something to compare against, don't you? Then you've got something that you are measuring using some traditional methods of measuring. And then you've got or utilization. So something along those lines. So if you've got like what does 20 gigabyte seconds look like on Azure Functions? How do you translate that to utilization? If you can find some mapping between that and that, either through researching academic papers, either through just playing mental, you know, not mind games, that's not the word I want. Is just or thinking through it theoretically, or running experiments using open source variants, and you can create that mapping. You've got an adapter model. You've got an adapter model. That's very powerful, and we need loads of them. We need loads and loads and loads of them. I think a lot of these adapter models you could probably just figure out by scanning research papers. There's a really wonderful piece of research by Hugging Face, Sasha Luciani by Hugging Face recently, which they talked about the carbon emissions of various open source, various AI services out there. You could read that paper and then infer from that what a ChatGPT prompt emission would look like, and then create an adapter model which converts ChatGPT prompts to utilization, and then boom, you've got everything else down the pipeline. That's adapter models. Scenario models are another really, really great idea. So what if you could just what if you could just drop a model at the end of the pipeline, which then adjusted the values in such a way to represent what if you moved from your on-premise to the cloud? What if you moved to different data centers? How would that look like? What if you made your application carbon aware? That's an interesting scenario to run. Like, without actually writing a single piece of code, if you had enough data in your manifest file, you could drop in a little model at the end and go, what if carbon aware? And then it could basically go figure out, well, if you were carbon aware, if you did run this code in France instead of the US, this is actually how your carbon emissions would go down. Scenario models, I think, are another really great example of something you could build with Impact Framework. Importer models, getting data to actually run all of this stuff is challenging. It's actually quite hard to even extract data if you're running lots and lots of servers on Azure or something like that. It's actually quite hard to get all the data into the manifest file and kind of get it all in that format of observation and YAML files. We need lots of importers. We're building the Microsoft team building an Azure importer, so you can import data from Azure. It's very challenging because there's 100 services, so tackling one service at a time. We need a GCP, Google Cloud importer, an Amazon importer. There's open source databases like Prometheus. You need a Prometheus importer. We want to cover like websites and web applications. For that, you need a Google Analytics importer, perhaps a Heap importer. We need ways of like getting data in. That's another great type of model to build for Impact Framework, and it really opens the door to every time you build an importer, you kind of like open the door to an entire ecosystem of people starting to measure software emissions. If you think about it, an imported model is because you're suddenly opening the door to them, to people who never had that ability to measure. Exporter models, like we're starting to build one now. Just export to CSV. Maybe you want to export to another time series database instead of where it is. You can just put a model at the end, and all it does, you're just giving it the data, and it can do what it wants with it. It can export it, it can save it to a file, it can do what it wants. And there's just kind of like a lot of types of models that we're kind of building. So importer models, adapter models, enrichment models is like getting grid emissions data or just enriching the data with other data that is useful for downstream calculations. There's a lot of that going on. Scenario models, I mentioned, cloud migration, carbon aware, those don't exist. Debug models, we're building one called Mock Importer, just to help, like if you're developing this stuff, if you don't actually have the data, if it doesn't really matter what the data is because you're trying to like craft a pipeline that just works given a set of data, you can just do mock import and it'll kind of generate a whole bunch of data for you. And then eventually you can plug it to the live feed and it will then like run live. There's debug models, like import, export models, and again, impact models. Sorry, I never mentioned impact models. So, we actually do need to measure emissions. So we've got like SCI based ones. Maybe you can make improvements to those. GHG, water. We have very poor, there's only about 10 10 basic models we've built right now, and we've got a very, very basic model for embodied carbon. We'd love to get more. We're much better right now at measuring energy than we are embodied. Um, we're struggling with like data sets to use here, so that'd be a good one. I would love to have a death model. If someone wants to go and create a death model, that's going to be my favorite model. I want to see a model where if you put the death model at the end of it will tell you how many people are going to die based off of your application running. And there's many bits of research you could pull to find the coefficients you need for that. But I think that'd be a very impactful model, very impactful. Air quality, lots of things. I want to go beyond carbon. So yes, if you want to like go for the hackathon, the website is grunsoft.org/hack/24. Please use that link if you're watching it from this live stream and you haven't quite got it. Yeah, please use that link from this live stream. And that's where you can pre-register for the hackathon. Just sign up. I think I forgot what the language is now. It's probably get updates, I think, is where we landed on. But just go click sign up, give us your email address and name, and we will just basically keep you informed with fairly regular emails, like once a week, just to let you know what's going on, when the platform's going to be ready, when we'll have other sessions to support our guidance for you. And yeah, that's what we again, it's called a hackathon, but we really focus on nurturing and providing an environment where we can all just we want you to succeed. We want all of you to succeed. Oh, there's no demo because I've got a new laptop. And that's it. So again, just sign up for Carbon Hack, grunsoft.org/24. Oh, so this is an old link. Apologies. The next session, it's going to be there's going to be a session like this every single Monday at the same time. So we'll send out links for that. If there's any questions, fire them away. I've got a question. Yes. So all output from the hackathon is public. This will be all made very, very clear on the hackathon platform. Everything's got to be open source. If you want to submit a solution, your solution has to be open source. That's just the nature of the hackathon. We want to make sure we create an open ecosystem, and so we want to support open contributions. And obviously the solution itself is impact framework, and everything that we do in the foundation everything is open source or Creative Commons. I don't see any other questions. So yes, that's a good question. There's a question from Emmanuel. What are you going to be evaluating in the projects? So, and again, we're just doing pre-registration, pre-interest right now. I'm trying to not drum up interest. I just know that it's going to be a long journey because Impact Framework is a very new space. So I want to start the conversations early. So depending upon the prize that you are working towards, there will be different evaluation criteria. So for instance, if you're building a model plugin, like one of those model plugins, it'll have a slightly different criteria to if you're perhaps creating if you're contributing to the framework itself, and all of that is going to be made very, very public. We'll tell you how. So basically, your first question is, what prize am I going for? Right? What prize am I going for? And as soon as you go for that prize, then you'll see these are the 5 things that we're going to ask about your submission, and this is how we're going to score it 1 to 5. So you can use that to judge yourself. What am I going to build? How am I going to build it? What am I going to submit? So we're going to be providing all of that to you. Just very generally, while I can quickly let me go, because it just hasn't quite reached we haven't quite agreed on some of the points here, but in terms of models like beyond carbon and the model, one of the criteria is going to be overall impact. What potential impact will this model have on the broader sustainability movement? How big a change will it make? What things need to happen for that impact to occur? What is the chance of your model like getting the impact that it needs? If you create a water model, big impact. What are the things that we need in order for that water model to be used effectively? Accuracy. How well does your solution measure emissions? Does it support both granular and coarse grain measurement? Innovation. Does the project bring something new to the table? Is there an existing solutions like this in the ecosystem? How is this solution different to others? And then overall impact, accuracy, and innovation is a common measurement criteria, but then depending on the prize, there'll be slightly different criteria depending on the prize as well, kind of extra criteria. So yeah, but that'll all be made public on the platform. Yes, that's coming up shortly as well. The user experience will be, there's a repository and a GitHub repository, and on there we are seeding on that repository right now suggestions and ideas from the team itself. And what you will then do is you will submit an issue, just a normal GitHub issue, on that repository for your project idea and your team. And then you put on that issue, like, I'm looking for team members. I'm actually okay. I'm going to do it by myself, or I'm bringing a team. You can put it all on there. You can put on that issue, I've got this idea, but I'm not really too sure, and I've got some questions. Put that on the issue as well, and we will jump in and, like, again, we want to support you. So we want to, if you've just got like a vague idea for a project, just submit an issue, a team name, and a project idea. And our goal is to help you evolve that into a real idea, which you can then hack on. But that's all coming through in the framework in a week or two. But that's all coming through there. If there's no other questions, 5, 4, 3, 2, 1. Okay, that's it. I think we'll leave it for today. Another session's coming next week. From next week onwards, these sessions are going to be live coding sessions, and I'm going to be bringing people in, and you can see from the team, like, how do we measure emissions. We're going to do live examples. I'm going to start off with an empty manifest file, and you'll see how we build it up. You see how we run. And over the course of the next couple of months, we're going to just be, measuring kind of different things, and you can start seeing how it works. And if you've got ideas for that, like, throw them our way. If you've got, ask them, can you show me how to do X, Y, and Z? Mention it on that call, and we'll just do lots and lots of live coding sessions. Is what's on the cards now, from now to the hackathon start date. So that's how it's going to work. Thank you all so much, and again, please sign up for the hackathon if you have not done so already, and we will send you information as and when. Catch you all later. Bye.